As you play around with scale, you're going to notice something weird about strokes. The stroke, of course, is the little line that gets drawn around an object if you have strokes turned on. As you scale up an object, not only does the stroke scale up as well, of course, so it stays with the object, but the stroke weight scales up as well. That means as your object gets larger and larger, the line around the outside gets thicker and thicker, and this is almost never what you want. Let's see this in action. Here's a sketch that draws a little curve. I can only control this thing in one way, and that's to scale it. As I move my mouse to the left, it gets smaller and smaller. When my mouse is all the way at the left, the shape is at its original size. So here I'm scaling it by 1, which makes no difference. As I move my mouse to the right, it gets bigger and bigger and bigger. To help us see what's going on, I'm going to draw some text. So this is telling us when we go all the way down to the left, where the scale is 1, that the radius is 16 pixels. That's the size at which I've defined it. Right now I am scaling it by 1, so it's not getting any bigger, and my stroke weight is 1 pixel. And if you look at it, yeah, it looks like that little black line is about 1 pixel thick. As I make the shape larger, notice that the black line is getting thicker. It's definitely not 1 pixel anymore. Now you might think, well, that's okay, this looks pretty good. And in fact, I think often it does look pretty good. So I'll tell you what, let's take this thing all the way back down to its size when I'm scaling it just by 1, and I'll make it half as big. Now it has a radius of only 8 pixels. The stroke weight is still 1, and sure enough, it looks like it's just 1 pixel thick. And as I make this thing bigger, that line looks like it's a little thicker than it was before, and it's surely not 1 pixel. If I wanted a 1 pixel stroke around the outside of this, I'd be very disappointed right now. Tell you what, let's do it again. I'll take this down to its smallest size, and now I'll make it half as big as it was. So I've changed the definition of this shape, so now it's only 4 pixels in radius. And I'll scale it up. Remember, the stroke weight is still 1. Well, that's really thick, and you know where I'm going to go. I'm going to do this again. So let's get this thing back down, and now I'm going to change the points. So the shape has a radius of only 2 pixels. And now as I scale this thing up, oh man, there's almost no shape left. It's all become the outline. And that's because the outline stroke is scaling up in thickness as the shape scales up. And if I do this even one more time, let's bring it all the way down. Now we have only a radius of 1. And now as I scale it up, we don't even see the shape anymore. All we see is the stroke. And the stroke itself looks kind of chunky. Tell you what, I'm going to turn off the stroke. There's our shape. And I can make the shape bigger and smaller. But as soon as I turn that stroke back on, it completely takes over. And this will happen to you all the time. It happens to me all the time. You scale up a shape, and suddenly all you see is a big black blob. Or worse, your whole screen fills with black. And you think, what's going on? Where are my shapes? Well, they're in there. Here they are. But when you're drawing that stroke, if you're scaling up the shape by a lot, here I'm scaling up the shape by about 300. If I draw that stroke, now the stroke essentially has a stroke weight of 300 pixels. So it's huge. Now this is not what we want. Of course, what we want is something like this. We want a nice 1 pixel line around the shape, no matter how big or small the shape is. I can even make the stroke thicker. Let's make the stroke, say, 9 pixels. And as it gets bigger and smaller, it stays 9 pixels, and it doesn't matter what size the star is. So this is the behavior we want. We want that stroke to stay the same weight, not this craziness where it just becomes gigantic as the shape changes. And let's actually look at this again. You can get these weird artifacts when the stroke scales up a lot. Just weird things can start to happen. So we want this. How do we bring this about? The good news is it's easy to make this work right. Suppose that we're scaling our object by some factor, and I'll just call it S. That's a floating point number. And let's suppose we want to draw a stroke with a weight given by W. This is the thickness of the stroke. And then we draw. If we do this, we're going to get that crazy behavior we saw before, because as the object scales up, the weight will scale up as well. So we don't want to say stroke weight of W. Instead, we say stroke weight of W, which is our desired weight, divided by how much we are scaling. That's the secret, and that's exactly what I was doing in the sketch to keep that line a constant thickness. This trick will work, but it has two conditions. The first condition is you have to know the scale factor. You have to know this value of S. In a simple program, you probably know it, and that's great. In a complicated program, you might not know it, and you might have to actually change your program so that you can somehow keep track of the scale factor so that you can pull off this trick. The second condition is that the scaling has to be uniform. Remember that scale can take two arguments, how much to scale in X and how much to scale in Y. And that allows you to scale in X and Y by different amounts, rather than the version we see here where X and Y are both being scaled by the same amount. If you do scale by different amounts in X and Y, this trick won't work. If you pick one scaling factor or the other, it will come close to working, but your line will not be of a constant thickness when it's drawn. So as long as you satisfy these two conditions, you know the scale factor S, and it's the same scale factor in X and Y, this is the trick. Let's see it in action again. Here we are where we started before. The little shape has a radius of 16 and a stroke weight of 1. And yeah, it looks like the stroke is about 1 pixel. As the shape gets bigger, the stroke definitely is not 1 pixel anymore. But if I scale the stroke weight by the scaling, then it is 1 pixel. Just for fun, I can make the stroke thicker. So let's make it, say, 4 pixels. And it stays 4 pixels no matter how big or small the shape gets. So let's make the shape very small. Now it is just 2 pixels in radius. And the stroke weight is 4, and I'm dividing it, and it looks great. If I forget to divide the stroke weight by the scale factor, I could get to this. And this can just drive you crazy. You think, where's my shape? Or you get a black screen. And you think, what the heck is going on? Well, the shape is still in there. I'll turn the stroke off. It's there, but we're drawing this big, thick stroke. If we weight the stroke, it's going to look fine. So keep this in mind. If you're using scale and drawing shapes that have strokes around them, remember to divide the stroke weight by the current scale.